So, our next speaker is Sandro Schulze, who also won an award for the most influential paper, this time from the 2013 edition of the conference, so exactly 10 years ago. And the award is for the paper, Does the Discipline of Preprocessor Annotations Matter? A Controlled Experiment. And again, the steering committee selected this paper based on the impact it has had, and still has, because one of the major deciding factors in the discussion was the fact that there was not just a high number of citations when the paper was published initially, but the paper is still receiving and continuing to receive a lot of citations. So Sandro, congratulations.
Thank you very much. Thank you very much.
And the floor is yours.
Okay, good. So everything off. Okay, so thank you very much. Yeah, for the warm welcome and for the award, of course. Yeah, you see the title is a little bit different, so it already has a little bit of the reflections that we did after we got to know about this award, right? So this is joint work together with Jörg Liebig, Siegmund, and Sven Apel, which are now at different locations. So Jörg is in industry, Janet is a professor for software engineering in Chemnitz, and Sven is professor of software engineering in University of Saarland, and I'm at the Anhalt University of Applied Sciences. So let's have a look at this gang of four one more time. So these are the four people. That's me and the other three, right? Back then in 2013, it was as followed. Those three have been at the University of Passau. So Jörg was doing his PhD, Janet just started a postdoc, and Sven was a leader of a research group over there, and I've been in Braunschweig. But we all got to know earlier in our academic career, because there's this fun fact that we all have a common origin, and that's basically the University of Magdeburg, where we earlier, 2010 and earlier, I received my PhD there, Sven received it way earlier, also Janet received a PhD there, and Jörg received his master degree there. Okay, so that just as a little information about the authors, and that sometimes everything has a common origin, right? One other thing I want to clarify here, I mean, the whole thing, or the whole paper and the experiment we did is in larger domain of software product lines. You may have heard about software product lines. It was once quite popular and maybe still in some areas. However, at some point we also noticed, well, maybe software product line is the wrong term, and so we came up with different terms like highly configurable systems or variable software systems, because there are systems that are configurable, but they don't follow a SPL engineering process, right? I may be a little bit sloppy and use these terms synonymously, so just that you know that I'm always talking about the same thing, right? And in the following talk, actually, I also don't want to bore you with all the details of the things we have done. Though the paper is out since 10 years, right? So actually, there are three parts I want to talk about. The past, so the years before and around the paper, and how it happened to be, and what was the context, why we did it. Then, of course, I will talk a little bit about the experiment we did. And eventually, I will, give our view why or which kind of impact we may have made with this paper. So we had a little bit of discussion in advance with the other authors. So what would we think, what was the main impact here? And I will talk a little bit about this one in the last part. But first of all, let's go back to 2013. Do you still know what you've done 2013? Or what happened around you in the world? Okay, give you a hint. There are some photos, right? So Steve Ballmer resigns as the CEO of Microsoft. If you're a little bit more in soccer, Frank Ribery was the European Soccer Player of the Year. Snowden, actually the Snowden files were leaked in this year, right? And he had to be fast to get out of the US and get into Russia. Then Barack Obama is sworn in for a second term as the President of the United States. Look, it's just 10 years ago. And so many things are happening right now. I guess there are a couple of people from the Netherlands. So Willem Alexander is inaugurated as king. Maybe you did not know, now you know. And there was this Euromaidan protests in Ukraine. So, which is also still kind of an everlasting topic, right? There were also some sad news. Some people died. Those three are maybe most famous, at least I picked them up. So Margaret Thatcher, the Iron Lady from the British Empire, died in that year. If you're a bit more in rock music, the second one is Lou Reed from Velvet Underground. Great musician, also he died. And the last one, maybe I most likely don't have to introduce, that's Nelson Mandela. Okay, that was 2013, just to get clear which year we are talking about. It seems to be 20 years ago. What also happened in 2013 is that I basically got my PhD, right? So very early in the year, if you see there's snow in the background. And then started as a postdoctoral researcher in Braunschweig. And also GPCE took place in Indianapolis, USA, right? So back then, that's very interesting, it was still under the URL program -transformation.org, and it had this very nice, icon featured, and it was the first year that GPCE was renamed. So until 2012, it was generative programming and component engineering, and that was the first year when it was generative programming, concept and experience. Just to get to know this. And Christian Kestner was the program chair. Maybe some of you know him. Okay, that's just a little bit on the background from an abstract point of view. So now let's get a little bit deeper into a brief history on SPL research around this time. And that is probably, I would say it's likely to be biased because it's my view, mostly, of these times. And the focus here is on how we came to this GPCE 2013 paper. So it means it's kind of a model view, right? So I leave out many details just to focus on what's interesting or what's important for this talk. Okay, in the very early days, there was a paper called If Stuff Considered Harmful from Henry Spencer and Geoff Collier, which was the first one I know that really, blamed the C preprocessor and using the C preprocessor, kind of these things. Some years later, independently, at the same year, at the same conference at ECOP, two programming paradigms has been proposed. That's aspect-oriented programming and feature-oriented programming by Gregor Sales and Christian Prehofer. Why I'm going to tell you this? Well, I started my PhD in 2010, and around this time, there was an intense research on SPLs with feature and aspect-oriented programming, right? So you found like features using aspect-J, aspectual feature modules, so we combine both worlds and maybe we get a better thing out of it. There were tools like Feature House for composing things, so a lot of things were going on. It was a little bit like a gold rush, so we have a lot of topics, right? Each direction was kind of promising some gold nuggets. So that was the time and how I felt this. However, I would say around 2008-9, we also realized that, okay, playing around with our feature and aspect-oriented programming toy examples is maybe a little bit too far away from reality. So what then happened was a shift towards what we call annotation-based variability. So where we have mechanisms, annotation mechanisms, that introduce variability directly in the language and not in some specific language constructs like features or aspects, right? This is also reflected by some papers I selected here. There was a paper called Granularity in Product Lines, which is well cited, that discussed the whole thing. Then we have the idea of integrating compositional and annotative approaches, and the idea of why not having a virtual separation of concerns, a second chance for preprocessors. So there are a lot of research around the idea, okay, how do we deal with these preprocessors as a language mechanism for variability, right? And what also happened then, that's why here 2010 is mentioned, is actually, that was my first GPCE and my first GPCE paper, and my first conference paper at all, if I can recognize correctly. So it was held in Eindhoven. It's a pretty nice time. And of course, it was about software product lines. I mean, that should not be a surprise now after talking about this for a couple of minutes. Second part, what then happened? So, well, around 2010, there was also more work on this preprocessor and the idea of analyzing real-world systems that use the C preprocessor to introduce these variable parts of code, right? And there are two papers that were kind of a foundation for what we've done eventually. Both of them were by Jörg, one of the co-authors, and one is an analysis of variability in preprocessor-based software product lines. So they took these systems and they analyzed, okay, how much variability is in there? How intensive is the C preprocessor used to introduce code that you can just remove by just switching the macro off or something like that, right? And the other one that was even more interesting for us was analyzing the discipline of preprocessor annotations. I will come to what discipline means here in a minute, right? So these two papers were 2010 at ICSI and 2011 at AOSD, which is now programming, right? Somewhat. And they were quite important for us. What also started to happen is that there's more empirical validation of SPL concepts and mechanisms. So far, they were just used and said, well, that's a great idea, let's do it, right? And then people started, okay, what about aspects such as program comprehension? Is that a good idea to use this or that mechanism, right? So we have the idea of background colors, we have the idea of comparing program comprehension between physically and virtually separating concerns. So it started also that there's some kind of empirical foundation. There's also other work, I mean, other studies for instance for verification, but that's a bit out of scope here. So and then eventually we arrived at the year 2013 where we said, okay, I know, just forget. I added one thing on the fly because when I arrived here today we had a brief talk, or Sebastian actually asked me why there are so few paper now at GPCE from software product line people, and maybe I don't have an answer, but what I want to say is that back then, the times I'm talking about, there were a lot of papers from, let's say, the product line community at GPCE. Actually, I would say GPCE was, we didn't crash GPCE, but we had a quite good coverage, I would say, right? I think in some I have 3 or 4 GPCE papers, so it's at some point diminished. I still don't know why, but just for those of you that are quite new, so there was a quite tight relationship. I mean, for years there was the workshop on feature-oriented software development co-located with GPCE, all these kind of things, right? Okay, 2013 then, our paper, that already has been mentioned, that, yeah, basically took the ideas from the analysis here part and added the empirical part on top of it. Maybe a little bit of context. I talk about preprocessor variability. What do I mean? This is a very, very simple toy example, right? Let's assume there's a struct, and we can decide whether we want to have a doubly linked or just a linked list. And then there is a macro defined for that, and if it's false, then of course this code is removed in a preprocessing step. So we only have a simple linked list. And if the macro is true, then we have a doubly linked list, right? So that's the idea of using this preprocessor directives, in this case conditional compilation, to introduce some kind of variability on configurability. And yeah, as I said, the 2 papers that were analyzing preprocessor variability were very important input for us. So what they have done basically is in the first paper to see how much variability exists in the systems and maybe on which level on granularity. Even more important for us was the second one, and that's how disciplined are preprocessor directives applied, right? We'll show in the next slide what does it mean. And as a consequence, so they were assuming, okay, having this undisciplined preprocessor directives is a bad thing. How to remove undisciplined directives. So that was this paper about. So now what do I mean by disciplined and undisciplined preprocessor directives or annotations? So basically the idea is if you have a disciplined annotation, then it is somehow wrapping whole syntactical units, something that is well-formed, right? And that you also then find in a well-formed way in an AST like this. Well, this is a whole function and it is annotated with an if, not if, and then an and if. So either you remove the whole function or the whole function will be in your program, depending whether the macro is true or false. With undisciplined, we mean that this happens on a way more fine-grained level, usually in some kind of non-well-formed syntactical unit, like here. You can do this also on just the parameter of a function, right? And say, okay, depending on whether feature GUI is defined, you use the one parameter, otherwise you use just false, right? So in a very fine-grained way. And if you have seen on the previous slide, the example, you've also seen you can do this on conditional statements and on all kind of things. So the preprocessor would allow. Whether you want to have it, it's a different story. Okay, and by default, it was considered harmful to do this. And there's a good reason I can understand this. If you look at some code, I recommend Vim for that. Then you can find really weird examples where people just cry and say, oh my God, what a mess. So that were at least comments we got in some other kind of experiment. Apart from having alternatives here, right? If, else, or having nested if there's here, these undisciplined directives are considered harmful because they may introduce errors. In this concrete case here, you get an error if glibc and use ISPTS flag are defined. Why is that the case? Well, here we have this undisciplined annotation. It annotates the actual if with the condition and the opening bracket. And here, there's another one that has some statement and the closing bracket. So now if glibc is defined, we will never end up here. But if use ISPTS is defined at the same time, we will end up here. So we have a closing bracket, but we are missing the opening one, right? And the assumption was always, well, that must have something to do with this weird kind of annotation. We don't do this at block level or whatever. We do that at an arbitrary level of granularity, so to speak. Okay, so that have been the assumptions. And there were the conclusion, okay, we need to abandon this undisciplined usage of preprocessor annotations. And again, if you look at this or even more messy code, you would agree, right? However, on the other hand, so far, until 2013, there was no reliable foundation. But it was just like, that's obvious. We shouldn't do that, right? And actually, there was no empirical insights on how the preprocessors understood in the one way or the other. So since that has been basically a mismatch, we thought, okay, let's change this. Let's try to put some more evidence in there. And that eventually led to this paper, right? So we wanted to turn assumptions more into a little bit more evidence, right? More evidence than, for instance, when you talk about the Balmer peak here. And we did a controlled experiment, right? Which basically means, controlled experiment, we take people, we put them in rooms, we give them tasks, we let them solve them, and then we check, okay, what can we find out? Here are the details. So there were basically two questions. We were concerned about, okay, do they solve certain tasks correct or not? So what about the correctness? Are there differences if we have disciplined or undisciplined directives? And what about the time? Is there maybe an issue in the time they require to solve these tasks? This is the setup we had. So we had eventually 19 students. They all were in an operating system course, so they had to develop their own operating system, a small one using C. So we could be sure that they had a decent knowledge, not maybe an expert knowledge, but a decent knowledge on the C programming language, right? We built two groups based on programming experience. Here on the right side, you see. So we did some kind of questionnaire, programming experience questionnaire. Then we did a weighted sum, and then we ranked this, right? And then we tried to equally distribute participants. We had one problem. There were 3 participants. They didn't show up for the initial programming experience interview, and so they had to do the questionnaire directly before the experiment, and we had to do a coin toss in which group they go. That's why we have this unbalanced groups, just in case you wonder. We had 4 subject systems, namely it was BOA, a web server, DIA, a chart application, some kind of IRC client, and Xterm, which is a terminal emulator. So different domains, that was the idea here, right? And systems where we knew, okay, there is preprocessor used, there are in undisciplined preprocessor directives in there, right? We knew this from previous studies. We had a disciplined version, and we did some kind of refactoring to turn undisciplined ones in disciplined ones, right? That, for instance, you can just expand the if-defs, then you have maybe 2 versions of the same function, like the one where we had the different parameters, just with different parameters. So usually making undisciplined code disciplined comes with redundancy. Something that you can observe quite often. We did some pilot study with graduate students and also PhD students to check, okay, are the tasks okay? Is the length of the code snippets okay? So we adjusted some code snippets when the feedback was it's way too long and maybe the time is not enough. We had a controlled programming environment that Jeanette developed back then so that we could track everything. So we could track scrolling behavior, we could track when they changed something where, all these kind of things. So a lot of log data we could use for reasoning afterwards. And there was a time limit of 90 minutes, which was quite tough. Right? If you've ever done controlled experiments, this is maybe the very upper limit you can have. Now just think of students, how long can they listen to you in a lecture, right? Okay, and then there were different tasks. We had some kind of, we call it mental simulation task, which is like understanding preprocessor annotation impact on program generation, like how many variants are there, which code is included, which lines of code when this is true and this is false, kind of these things, right? Just mentally understanding what's happening. Then we had maintenance or evolution tasks, where they really had to change stuff, right? They really had to do some changes on the code. And then we had last task where we have, it was different, we detecting or fixing errors. So it was different because there was now the same code, so both became the undisciplined code, but one had to fix it, one had to detect the error. We'll come to that. So there's an example for a mental simulation, like for a given configuration here, determine all lines that belong to method check term code, right? And then we gave them a certain configuration, which means stating which macros are true, which are false. For maintenance tasks, it's like extend term resize by a new preprocessor variable for changing the width only, so they need to introduce this in the right place so that this newly introduced macro is wrapping the right lines of code so that just the width is changed. And for detecting fixing the errors, I said it's different. So it's the same code. Beforehand, there was one group getting the undisciplined and the other one the disciplined version. And the task is different, so it's, for one, they had to resolve the error, and the others had to spot it. So what about the results? First of all, we're interested in correctness. See, okay, are there differences? For instance, the assumption would be, based on the assumptions made by previous work is, okay, there must be a clear difference that those that use the disciplined versions should perform better. That was basically what others suggested. When you look at this, I mean, there are differences indeed. We also introduced a 3-point scale. We found out at some point, well, they solved it in a very good way, but they did not realize that we have 2 files, not only 1 file. So they solved everything in 1 file and forgot the second file. So kind of these things, that's why we introduced this almost correct. It's a little bit sloppy, I know, but at this point, we found this quite fair. What you see is that in general, there's not a huge difference. There might be here and there a difference, but not very much. So we also performed some statistical tests to see whether there was a significance, and it is not. That means there was no difference in the correctness of solving these tasks between the disciplined and the undisciplined group. What about response time? So that are the box plots for the response times, right? What we can see here, they are close by for each task. It is even the case that the response time for the undisciplined group is lower. That means usually this undisciplined code is a little more compact, and it seems to pay off, at least regarding the response times, compared to have a large redundant code base there when you do certain tasks. There is a large difference, however, for task 7, right? So there's way more time required for the undisciplined group. However, tasks were different here, so it's still a little bit inconclusive. Overall, we can see that, again, there are no significant differences, and there is a slight tendency even that this undisciplined group is faster. We also checked a little bit of our log data, right? So to see, okay, what can we find out here? We found out that most of the participants followed a similar process. That means the way they scrolled the code, time that they spent at certain parts of the code, the changes they made to the code. So it seems to be quite consistent. So otherwise we could say, okay, this is so heterogeneous, there's not very much in these results that you can report. And There were also people with totally wrong answers, right? Where we are not entirely sure what happened, but we found out that they never used the code search. So they could have used, for instance, for the macros, they didn't do this. So maybe that was the problem, but maybe they also were just kind of, yeah, gone. For the maintenance task, we found out that 4 participants had no idea how to solve things, right? Again, I was not really clear why, because they did changes in parts that were absolutely unrelated. If there were mistakes, so like usual programming mistakes or something, they were quite similar, like they introduced the correct variable, the correct macro, but they missed to move some code out there. So there was too much code in this macro, kind of these things. And then we found that 2 participants made syntax errors. That was misplaced bracket, where we would assume, because they were in the undisciplined group, that it was likely because of the undisciplined annotations, so similar to the example I've shown, right? Okay, then there are the research questions to answer, right? In both cases, there are no significant differences, and at all we could say, we couldn't find any evidence that there is a difference. In particular, that the undisciplined usage of the preprocessor is worse for program comprehension than using the disciplined ones. Okay, I'm coming to an end now. That's the last part. What do we think? What's the impact? So we did some statistics. So I did statistics in a word cloud, right? So there are also these numbers, like we have 63 citations. As Kuhn said, it's like quite equally distributed. The highest peak was in 2016. What I found most interesting is when you look at this word cloud and ignore the typical words like preprocessor-based or systems, is it seems to be, I mean, it's a word cloud of all the papers that cited us, and then I use the titles, put them in, and that's the word cloud, right? Study and comprehension is quite huge. That means there seem to be a lot of papers that also did some study on this program comprehension thing. There's also some eye tracking, mid-size, right? So, yeah, it seems that we could at least trigger people to do more studies on what's going on with this preprocessor usage. And if I have a closer look at the paper, there are a lot of studies. There are human-related studies and what would call it subject-related studies, more case studies on systems. So this is what I found at a first glance, all paper that did studies with humans to get a better idea how the C preprocessor is understood, right? There's one that we did, okay, I'm honest, but all the others are from different people that try to figure out, okay, what's going on there, how should we deal with that, because our results were initial, but still inconclusive, and you can still find out more. And then there are some studies that just did more analysis, like, is there the maintainability affected, does it influence the occurrence of vulnerabilities, is there a difference between open source and industrial software systems? All kinds of studies about using this preprocessor-based variability. Oh, and I'm especially proud of this one because here we got the 2017 GPCE Best Paper Award. So just, you see, GPCE played quite a pivotal role in my previous life. So summing this up, what do you think is the impact of this work? I would say, or we would say, that first of all, we put the human back in the loop. Right? So far there was, okay, man, it's preprocessor, it's undisciplined, you shouldn't use it. But there's always a human side when talking about program comprehension, so we put it back in the loop, and others then followed up. In a broader sense, we would say that we did some foundational work to introduce experiments as empirical methods in this line of research. So many others picked this up later on, right? You've seen a couple of papers. So I would say that is another impact that we had when we did this. Right? I mean, there have been some studies, but doing this in a controlled experiment with people, that was kind of, I mean, it was not new at all. I mean, we didn't reinvent the wheel. The method was already established in other fields, but in our line of research, that was quite the starting point, and others then just got crazy. Well, and as a third one, I would say we eventually, at this point, refuted the assumption about undisciplined annotations. So that maybe they are not as bad as they are blamed for. Okay, last slide. For you guys, what's the takeaway message for you probably today? I mean, you built great stuff around PLs, right? We've seen a couple of things today, right? Like Someone's talking about this architecture description languages. Markus was talking about this X-text, X-base. However, we should always, I mean, if we do something that is directed towards the end user, the programmer, we should still have in mind that despite ChatGPT, all of this is used by human programmers, right? Code is still written by humans, and I'm pretty sure that will be so the next 10, 20, 30 years. So the question that I would ask you, or that you should ask yourself, do you think about this when you're designing things that programmers are using? And do you take the consequences into account, what may happen or not, regarding program comprehension, regarding maintenance, and so on and so forth? So that's just, I mean, hopefully not too offending. You need to check the reality, right? We need to focus, and that's what we learned here back then, on the human in the loop. And I think that experiments at some point, not always, but at some point are inevitable. And we shouldn't ignore this empirical line when we just go ahead with all these fancy theories and whatever languages we create. Thanks a lot.
Thank you. We have a question from the room already. That's great. Keep them coming.
Thanks, it was a wonderful talk. So if in the end you sort of come to the conclusion that the disciplined and the undisciplined approaches are not that different, does that mean they're both terrible or they're both good? Because you know, when I certainly have that same first impression of the undisciplined is obviously a nightmare. You should never go down that road. But you know, so yeah, that's my question. I guess.
Yeah, that's a very good question. Thanks a lot. I mean, that's still the. I mean, I probably can't answer this entirely. Whether they, the point is, it is used quite heavily. I mean, if you look in Linux, you have more than 10,000 of these options. So there's obviously something that makes this inevitable to be used, right? It's powerful. You can tailor everything you need. Maybe you should ask expert C programmers, not me. I would say I would go with the answer that now I would say they are both, or the undisciplined are less terrible, but wouldn't agree that entirely that the whole thing is a terrible thing. I mean,
if I could follow up, is there a different definition of undisciplined and disciplined? That you'd say there are sort of good ways to use this.
Actually, this
syntactic structure is not quite the right.
Yeah. So even when Jörg did this analysis 2010, 2011, he double checked also in some kind of project, and there are usually guidelines how to use it, and the usage that usually is favored is the disciplined one. So you should align with these structures, kind of these things. That is actually what you find in projects. Still, it seems that it happened differently. I mean, when we did a study and we sent out questionnaires to open source developers and got a lot of feedback, and there was like along the line, so in these free text sheets said like, we use it, it's important to use it, but many said we should abandon this undisciplined usage. Again, when they performed some tasks, we couldn't see that there's a huge difference, right? But from a subjective impression, I guess even developers don't want to have these things. I don't know how this happened then in Vim. There you can find really crazy stuff. But coming back to a question, there are indeed guidelines on how to use it, and that is usually more in line with the disciplined ones.
Hi, thank you for the very interesting presentation. Looking at the data from the actual experiment, it seems to me that there's a large proportion of wrong answers. And I actually wanted to piggyback on the previous question on, did you guys look at all at the, let's say, the cost, both mentally and so on, of actually applying at all these techniques versus something external, for example?
Of course, you always have this in experiments. We try to control, and you can find details in the paper, possible confounding factors that may exist, right? I mean, the first one is that we have equally equipped groups. Still, they have students. I mean, they are not expert programmers, but still, we didn't give them the whole code base. We picked files. In these files, we removed anything that is not related, like too many comments, so that the code is not too long. So we tried that they to keep focus. They didn't know about discipline and undisciplined annotations, but we also did an introductory presentation about preprocessor usage at all. So we tried to somehow control confounding factors as far as you can. They were all sitting in a room. That means, I mean, they couldn't just go up smoking, getting a coffee. I mean, they were yeah, kind of these things. Yeah. Still, of course, yeah. There might be something that we didn't have in mind, but according to the standards that you have for experiments, we were pretty much careful in fulfilling that.
Maybe this one will inspire some more questions. So I'm a big fan of evidence-based software engineering, and we see a trend there into, well, people are starting to replicate previous studies as well to make sure that all variables were controlled for, etc., etc. So have you seen some replication studies of your own experiment already?
Not really replication, but I would say something that was in a similar direction, usually maybe extended. Right, so there were a lot of things done, especially by colleagues from Brazil. They even then started to experiment with eye tracking and kind of these things. But I would also say that that's maybe now something where I have to blame ourselves. Back in 2013, it was not common to have a replication package.
That was my follow-up question.
And I guess we still have everything, data, and we have the questions, and we have the code snippets. Maybe we should do some kind of posteriori replication package for others. But back then, you know, that were different times. So good that we have the times how they are now. But back then it was like, okay, right? I mean, maybe there was some kind of zip file that you could upload at EasyChair or something like that, right?
Right. Other questions? Yeah.
So, hello. So I want to steal your question from before. If you would do it again, would you look at something different? For example, this almost correct part. Would you implement this, or would you consider this beforehand, or what would you consider if you do it again?
Definitively, we would maybe think in advance how we would maybe deal with this one, or maybe how we can prevent this. It's always the same, right? If you have a very small code snippet, you can control it more. There's not that much, and if you just let them do some single choice answers instead of doing some stuff, but then you get less insights, especially on a for the qualitative analysis. But that would be definitively one thing I would do differently, or we would do differently, that we, with the knowledge, there's something that is almost correct, how do we do it, that we in advance would check. How do we evaluate this, or how do we prevent of this? What could we do? A different one, I mean, there's always what you would like to have is like larger groups of participants, more proficient programmers, but that's usually a different thing if you can't throw with money, right? I mean, that would be another thing that would be quite nice. And maybe today, just to add this up, because Jeanette and also partially Sven are a little bit more in now looking really into brains of programmers. Maybe we could add this on top, like with fMRI stuff, really looking what's happening, right?
Yeah. Also, you mentioned the participants. Like I think you had here, it was like around 20.
Yeah, 19 at all. Yeah.
Yeah. So, would you feel that if someone does this kind of human in the loop study? Does adding more participants give you like a better confirmation of your claim, or is it sometimes even better to have like less and then go in on a more qualitative analysis?
It depends on the study. There's one paper I cited on the other that was this love-hate relationship where they did interviews, right? If you do this one, of course, then you're fine with less, but then you can ask more intensive questions, kind of these things. And of course, more is not always better, right? But in such a case, if you have more, at least you can say, okay, we find a similar process for 20 participants, and we find that 100 participants applied to a similar process has a different strength, right? But I would even say that more is not better, but maybe different levels of experience would be nice to see how does this differ, right? How does a 5-year, let's say, 5-year experience software developer differs from maybe a student in the 3rd year or something like that. That could be even more interesting, but that's even harder to do because it's harder to get developers.
Thanks for the great talk. I was wondering whether this kind of study, can it be applied to kind of more modern languages with like more modern support for pre-processing?
So which language you have in mind? Which
I don't know,
mechanism?
let's say Scala with the macro system or Julia.
I think the setup itself can be applied. I mean, you just need to find code that you need to define for your language mechanism and your mechanism what is disciplined and undisciplined, maybe in a similar way like here. The setup can, I mean, it can be applied. The point why we applied it here is because, especially in C systems, I mean, you have this wide variety of C systems. They are well matured or not. Yeah, there's a large corpus and yeah, that's, it's just used, right? It's a matter of fact, I don't know how often people use mechanisms in Scala to introduce variability. So I don't know, right? For C systems, that's very clear, right? And you can, I mean, there was this one study of Jörg, find out, okay, up to 15% of the code maybe is variable or something like that. But in general, the whole setup and the experiment could be also transferred to a different language with a different mechanism, that's for sure.
Any other questions? Give me maybe the final one then. So you mentioned during your talk that when people go from undisciplined annotation usage to disciplined, that often times the code size increases. Is that still a problem nowadays, or is that something that PL researchers can work on?
No, I mean that's just in the very nature of this disciplined annotations, right? If you take, let's go where it is. If you take, no, wait, this example here, right? If you want to make a disciplined one, that means you make the method call 2 times, one with one parameter or argument and one with the other, right? So that's just like in the nature, and I don't see how this, I mean, there's no abstraction mechanism in C that you could use, so nothing like inheritance or whatever.
So we need better language.
And even then, kind of these. So that's quite natural that this increases the code size, but still it seems to be, at least according to some guidelines, considered less problematic than having these undisciplined annotations.
All right, so maybe that's something for future work, for your next GPCE paper, who knows?
Let's see.
So congratulations again. And,
thank you very much.
Thank you.